find the absolute extrema of the following function, well, there's only one, on the given interval. So basically, notice this is an open interval from 0 to 1. So what we are taking out is, we're not doing the limits as x approaches 0 and x approaches 1. We totally could, but by showing it's a max or a min, we're proving that it's an absolute max or an absolute min. All right, so what's the first derivative? Yes, we're doing this. Great job, everyone. So let's see where this derivative equals 0 and does not exist. I'm going to rewrite 1/3 x to the negative 2/3 as 1 over 3x to the 2/3. Because that way we got rid of negative exponents. So how should we solve for x here? Besides screaming and running away, that doesn't help anything. Yeah, let's bring that 2x over to the other side. Yep, multiply both sides by the denominator there, so that would give a 1 on this side. So what do you get on the other side? So what's x to the 2/3 times x to the first? X to the 5/3, because when you multiply two things of the same base, what do you do to the exponents? Add them. I'm going to write that a little bit lower. It doesn't look like an exponent. That 1 centimeter down makes all the difference. So how do we solve for x? How do we continue to solve for x? Divide by 6. And how do we get rid of a 5/3 exponent? Take both sides of the 3/5. Yep. Sure, so we multiply both sides by x to the 2/3. Well, actually 3x to the 2/3. So the 2 and the 3 made the 6. And the x times the x to the 2/3. Correct. So we're going to raise both sides the 3/5 power. So we're going to get a decimal here. So if you would round this decimal 2 decimal places, you're going to do 1/6 to the 3/5 power. When you put 3/5 into your calculator, what do you need to put around it? And also the 1/6, what do you need to put around it? Parentheses. Is 0.34 in our interval from 0 to 1? Yep. Oh good, we're halfway done. Because now this was where the derivative equals 0, so now we have to see where the derivative does not exist. Oh, I haven't used this in a while. So looking at this guy right here, because this is our simplified derivative highlighter that you cannot see anymore. It's okay. Notice we have a fraction. What value for x would be bad there? 0. So x equals 0 would be another critical number. But is 0 between 0 and 1? Is 0 greater than itself? No. It's equal to. So this is not under consideration. We don't care about x equals 0. Okay? So this still holds true. We only have one critical number on our interval, namely at 0.34. So if we show this is a max or a min, a relative max or a min, we instantly show that it's an absolute max or an absolute min. So how do we show it's a relative max or a relative min? So put your critical numbers on a number line. Give me a number to the left of 0.34. To the right. And where are we sticking in these numbers in? Into the first derivative. You know what? We really can't use 0. Let's use 0.1. So put in 0.1 and 1 into the first derivative. We don't care about the value, we only care about the sign. What does 0.1 give us? Positive. What does 1 give us? So the graph goes from increase to decrease, which means 0.34 is not only a relative max, it's an absolute max. Now we need the y-coordinate at 0.34. How do we find the y-coordinate? Into the original function. So if you would, plug in 0.34 into the original function. What do you get at 0.34? 2 decimal places is good too. 0.58.